Hello class, this lecture is going to cover how to convert this model of this assembly model into a detailed drawing, accounting for all the changes that you see on the right side, where you have to create a bill of material per specific standards of a quote-unquote company, our company, and how to make that work inside Solidworks itself. So first off, here's where we ended up our last video. We went ahead and assembled everything. It's made it together. Nothing is moving. What's missing are the fittings in question, the fasteners. So we have to look at what items we wanted to add on the fastener list. We don't want to make custom fasteners. We want to make purchased items. So when you're working on purchased items, you're looking at, I have to maximize this. You're looking at the two different type or three types of items in here. We have a M12 flathead machine screw. We have an M20 2.5 hex head nut, and then we also have a M20 hex head bolt, 60 long. They're metric components. So we have to jump online. And the best place to go for this information is, in my opinion, jump over to McMaster Car, because for me, at least, I tend to find everything I'm looking for over there when it comes to downloadable images that I can utilize in my drawings. And that's very useful for this, because you don't want to create fasteners from scratch. So when we jump into McMaster and we look at the item that we're looking to identify here, we're looking for an M20. So I'm going to just type in here an M20 hex head bolt. And as you do this, you start seeing different components come up. So it's a screw. Look at that up, hex head screws. Bolt screws, they tend to use the term not so interchangeably, but on McMaster's website, they're calling it, they put them together, screws and bolts. So it's metric, M20, you can find that. Now the length of it, it's 60 long, so it's 60 millimeters long. And then it doesn't tell you the type of fully threaded, partially threaded, but you can tell that it's partially threaded. So if we pick partially threaded, we only have one choice. There it is. What's awesome about McMaster is you have the image, you can go buy them, these are expensive. And there you have the drawing for it. So for your PowerPoint, if you were going to do one, which is a simple way to do this, in your case, you're not creating a PowerPoint for this project, but you are for your final project. Whenever you use a standard item, all you have to do is use your snip tool to go ahead and snip the item, and then you can turn around and paste it into PowerPoint, whatever it is that you want to pick. I just randomly selected something just to pick it. So when you look at this, if you wanted to literally just make sure to delete the other stuff that's on here when you are going to do paste. You see how it creates all these little text. Delete all that, then you just go ahead and paste yours. Remember, when you do drop these images, only expand them by the corners, because then the image is not distorted. Never stretch them out. Okay, guys? Okay, so just a heads up when you're creating the PowerPoint. This is more for your final project than this one, but just because I'm in the middle of it, I'm letting you know how to do that. So that's the best part. The next part that's totally awesome is you have the ability to download the files in multiple platforms. So you can do an SAT, a PDF, a Solidworks, a step file, and you can even send in regular drawing files, literally just normal drawing files. So in our case, we're going to do a 3D Solidworks file because we're in Solidworks. If we were using Inventor or some other product, we would want to use a step file, STEP, or an IGES. But since we are utilizing Solidworks, and that is what McMaster-Carr uses, it's native to them. That's why you can just pick Solidworks directly. When you hit save, make sure you know where you're saving. It's always the big question. Where did it go? So in our case, I went to downloads. So if I jump over in downloads, there's my file. Now you're going to notice I want to move it. We covered this in a previous lecture, but always make sure to keep your stuff in the same place. If you don't, the chances of you disconnecting your parts from your detail drawings or your assembly from your different components from your assembly is pretty high. That's why you see me immediately copy and pasting it in my folder where I have my assembly project. Make sure to do that with your work as well. It'll make life so much easier because then you'll know where everything is. So that's part one. Okay, the next part, let's see, it's over on this side. I wish it would let me pan. I don't know why it won't. There we go. Okay, so now I'm looking at these guys. The M20, that's the next item. So it's another M20 hex head bolt. It's another hex head bolt. Again, metric, M20. This time it's oh, this is the nut. Okay, that's a bolt, so we're not gonna find the, let me just pull up nut. Metric. Hex head. Say nut class 8, doesn't really matter. It's 2.5. 2.5. I can't find hex. That's standard profile. M20. And you'll notice I don't have a choice. 2.5 is the pitch information, but it doesn't, I don't have any type of choice. I can only get 16 millimeters. So as long as no one insisted on a different size nut, which nobody has, we're in good shape. Now, when we look at these, we have 3 choices. The customer has not specified what type of finish they want on theirs. Zinc plated, black oxide, or steel. Steel is perfect for welding, which this isn't going to be welded. That's why it's so expensive. Zinc plated, you cannot weld, but it's shiny and resists corrosion rather easily. Black oxide is the cheapest because it basically has a little oxide coating on it, like a black coating on it, so it's easy to scratch, which will then make it want to rust. The customer told us nothing. Normally we would pick zinc plated. You guys tell me which one you want. Any preference?
The black oxide.
Exactly, because we're cheap. So when you have choices, now you have to think about, why am I choosing the part in question? That's usually a design question that we have in a different class. So now here too, we can go ahead and do the snip. Okay. And you notice how I do it immediately. That's my advice to you as well. When you're working on your final project, you want to just make a habit. You start your PowerPoint right away. The first things you put in it, I'm going to pick blank. You make sure you put in all your purchased items, if you have any. If you're working on your PowerPoint now for your final project, you're ahead of the game by miles. Don't wait till, the week before, now I'll put it all together. Don't do that. Put as much together as you can. It will save you a ton of work later. So now this also, I'm going to hit save. I don't have a choice of save as. You'll notice that. I can either open it or save it. So I hit save. Again, the same thing I did last time. I make a point of finding my file immediately, okay? Copying it and pasting it in the correct home. That way I don't have a chance of losing it. I want to put it away right away so I don't have any concerns of what am I doing, you know, where did my part go? None of us have ever lost any files, right? Yeah, I have, I'm honest. So next, the flathead machine screw. Okay, now it's got a slotted head, so it's a slotted flathead to be specific. It is metric, so we're going to pick metric. And then we want an M12. And then we only want it to be, well, the thread information. How long is it? 35 long. There we go. 35. Okay, so there it is. I only have one choice. Whew. Stainless steel. Nice. Expensive, by the way. All right, so I'm going to open this puppy up. Same thing. Copy. See that? And snipping. I'm using the snip tool. If you don't know where snip is on your computer, just type in the word snip in your search area and it'll come up. I have it, I use it so much, I have it pinned to my taskbar. So, and then you can just go ahead and use slide. I usually pick blank because I'm lazy and I don't want to have to erase anything. And there you go. Now I've saved my parts, minimize this. Okay. And then that's for the PowerPoint. And this right here is for creating the assembly. So again, the same thing, same runaround. I'm going to open up. So I'm going to try to do this like this. We'll see what happens. Where's downloads? Where's downloads? There it is. This is the new item. Yeah, I'm not going to be able to drag and drop, but at least I might be a little faster. Copy. And then go find my folder. Class, assembly, paste. There you go. Uh-oh. I don't want to copy the entire downloads folder. And that will happen as well. I just want to copy you. Copy. And paste. There we go. So now that everything is where it belongs, doing an assembly is easy. When you, trust me, you really do want to make sure all your components are together with your assembly before you start assembling. Otherwise, you will disconnect your parts. I think there was another video that I did that showed this. Because I think one of you had this problem. George, I think it was you, right? I think you had like changed your file name or something.
Yeah.
So please be fully aware of that, all right? Please don't, I'm gonna put you down here somewhere. Please do not assemble it and then start rearranging your files on the side later, because I guarantee you will have this problem. So here's my assembly, and I'm gonna just go ahead and insert my new parts. Okay, the browse. I can pick all three. Now you'll notice where they are. Where am I automatically picking them from? Do we know? Not really. So that actually is in downloads. So I stop myself. Don't do it. Don't do it, because you're going to have that problem. You have to intentionally navigate to the correct location. It's an intentional act. You've got to do this carefully to save yourself headaches later. Okay, now you can pick all these, all three. Hit open. Okay, and just drop them in. Done. Okay, Now is the same process. Now, some of you are going to ask me some questions. I'm going to try to give you some answers, but I'll probably have to do a different video to give you the real answer. Now you have, which is making the insides. Why are the insides? We have some small issues. Let's move this aside real quick. The things that you're going to question me on, well, I would like to think you will, is you'll notice in these cases, everything is through a hole, except for down here. In the base, it actually is a threaded hole. Nothing up here is threaded. Nothing in the body is threaded. Only down here. So we will deal with this last. For assembly, let me maximize this. The same method we've used before. Pick the side wall, pick the side wall, so it just pops right in. That's the easy part. This one's a little more interesting because you're trying to pick the flat, round part. And as you could tell, it's fluted. So you actually have to pick that inside flat edge to get to its real center. And it's complementary. Edge there, and what you want to do is not tangent. See that? When it made a tangent. Not perpendicular. You want a concentric. Notice it doesn't want to do that. Whereas when it was round, the other item it did. Why? Because what you're picking, it doesn't see it as a round object. So what you want to do to try to connect objects like this is you could go under hide and show temporary access so you could see the centers. And what you're really mating are the axes. There you go. That's how you get it, just to do it, be done with it. Because it's hard to do this with fasteners. And then this with, I don't have a center on you, do I? I have you. There you go. You're upside down. So I flipped the direction. I know it dropped all the way down there, but that's easy enough just to pull it because they're connected by centers. Just pull it up. Now this looks good. That's a good fit. This, okay, I want to drop it in. Let's see how good of a fit this is going to be. I'm going to pick that wall. I'm going to pick this wall. I'm just going to make those two. Now the way I did that, quick thing, I used my control key so I could pick both objects, or you can go into mate and do it that way. Pick you and pick you. They didn't connect. Let's make them coincident. They don't want to match up. So there's something's off. So the way I'm going to test it, I'm going to pick the side edge, hold my control key, pick the side edge. It's made it this way. Tangent. Does not want to connect at all. So what could be the problem? I'm going to go to mate one more time. This time I'm just going to do flat to flat. I'm going to pick the top of the object and I'm going to pick the top of this body. Boom. Whoa. Aha. Now we see the problem. Who noticed that there was a problem? Who's done the assembly yet?
Yeah, one of the problems was the angle was 82 and the other one is 90.
Yeah, the angles are bad, as you could tell, and the diameters don't match. Because as you could tell, there's a serious interference fit.
Yeah, the diameter of the body, the screw is different than
Exactly. So if I look at the evaluate option inside SolidWorks, this one's pretty obvious, of course. I pick the two objects in question and I hit OK. Oh, come on. The interference, if I look at this object and this object, I don't need the assembly, but those two objects, these two objects right there, I don't know why it's, there you go. It's got an issue there. It should have made the whole thing red, and it may have, it just because, let me try it one more time. Interference detection. Well, you've got, we'll just pick the whole object and be done with it. And what it's doing now is calculating everywhere there's an interference, and there you go. That fastener has a serious interference fit. We know that already. We could see that it's there. So that has to be resolved. So there are two approaches to resolving it. One thing I do recommend before you try to figure out how to resolve this, I do recommend that you do a section view. And you see how, let me show you how that worked. You click section view. It'll automatically pick the front view, but you can select a different view. For example, you can pick this one or this one, see that? So you could slice it different ways, but it picked the front plane. I didn't literally slice the part, but I am now seeing through it, so I can see rather clearly where my problems are. This side, we're good. That's a clean fit. It's tight, but it's a clean fit. This side, however, not a clean fit. If I do the interference between these two objects, just calculate it, just the whole assembly. Obviously down here, because I think I forgot to put the holes in, and amazingly it's not showing, there you go. It should show all, there you go, that's the one I wanted to show you. This head, see that? Doesn't work. So to fix this, you have two approaches. You go and find another fastener, but were we able, how many fastener choices do we have when we pick this one? One, right? At least on McMaster-Carr's website. We only had one choice. Now, of course, we can sit here and say, well, I'm going to go find a vendor for exactly this match. No, companies don't do that. We're not going to waste the time to do that. What we're going to do is pick the standard fitting that we have from our vendor that we normally order from. And we're going to make a note to our customer that it has to be changed. But what has to change? We're going to have to change this item, right? This particular part has to get changed. So we can do that on the fly, this part right here. I can go ahead and edit that part in place, just like I showed you with the visor video that I had posted. And this particular part has to be fixed to reflect what can physically be done. So in our case, we've got that hole's good, this hole's the problem. So if I edit that particular item, because I saved my image file over here in PowerPoint, I don't have to hunt that puppy down online anymore, right? Because I could see what the angle is if I split my screen. The angle is 90, mine was 82. So we got to change that to 90. That's step number one. Okay, what else is different? The diameter, if I look at it's a 22 diameter head. And this one's 14 diameter at the bottom. 20, whoops, yes. 14 millimeter diameter, depth, countersink diameter is 20, and obviously that's too small, so I need 22. There you go. once I make those two changes, any of us who've ever worked with any type of fasteners, you can't do 22 as the countersink, by the way, unless you make it just a hair deeper. You typically have to go just well, even if, you know, if you go, no, you could do it. If you go 22, you're gonna end up cleaning it out a little bit so that the fastener sits flush. It has to sit flush, and I'll explain why. So if I hit OK now it's a perfect match. In a perfect world, you can make fastener holes perfect. World is not perfect, by the way, so typically we do make it just a little bigger because this has to be flush. You can drop in a little bit, but it has to be flush. And the reason it has to be flush is because look how much room I've given myself between my other bolt and this fastener. That fastener must be completely flush. Now I showed them on different sides, you'll notice, right? I can go ahead and mirror my components if I wanted to. These two items, this one and this one. Come on, you. Those two items. And the mirror that I'm going to mirror along that edge, the right plane, these two items. When I hit OK, boom, I got them on the other side. Could I have done the other one at the same time? The answer is yes. So I can go in and edit. That's the nice part, edit my mirror and pick this one, literally at the same time. Go in here and pick this guy. See that? And hit OK, and boom, I got all of them in at the same time. Isn't that cool? Okay. I'll uncheck this. Now you'll see the fasteners are exactly where they're supposed to be. But you can tell that you have to change the fastener that was, I'm sorry, change the configuration of this one part to accommodate the fastener. What's nice is because I did it in assembly, when I go and open that part, this has been adjusted to the parameters that we had to adjust it to. It's perfect. So no extra work has to get done. I don't have to go and fix my component and then go back to my assembly because I edited my component in assembly. That is how you need to work with your final project. I'm doing a save all to make sure I save, and save often. Please remember this. This is very important. This is how to fix components in an assembly. Don't go and open that file and then edit that item separately of your assembly. Edit everything in assembly. So the sooner, the lesson of the day, the sooner you start your assembly file when you're working on your final project, the better. Because that's how you're going to be able to tweak your parts to make sure they're correct. All right, guys? Next, I am a huge proponent of trying to line things up properly, so I don't want, if I look at my top view, I am not interested in seeing my slotted fasteners goofy-eyed. When I look at the end view, yeah, this is not perfect. See how I can clock it? I don't want it to be at some odd angle. So I do want these things locked in nicely. So I am going to go ahead and do that because that's just how I am. And trust me, it's good for the employers as well. You want neat looking drawings. So I'm going to go ahead and make these two so that they're flush. See that? And then this guy and this guy. Uh-oh, I just want them to be parallel. Nope. See how that worked out badly. So we don't want that. So what's a good way to do that? I can instead go to mate. I can pick the side wall of the fastener and the side wall of this, and it clocks beautifully. And the other one clocked beautifully at the same time. They are married to each other because they are mirrors of each other. Okay? Keep that in mind. So now this is locked into place, not this way, See that? They pull out, but they don't turn. These guys, see that? Now, one thing I would advise when it comes to making the assembly is probably to have your fasteners out and away from the part versus in, because I don't know if you noticed there, it's visually challenging. If those of you that have done it, like Sadi, may I show them yours? No? All right, I won't. Let's look at this real quick. So,
Yeah.
okay, yeah, okay. Well, don't worry about it because, whoops, I'm opening up the wrong file. Don't worry about it. I don't want to go into emails right now anyways, because then I'll start getting my email announcements. Notice the mate here. Something's upset. This guy, parallel. Why is this one upset? Fine, I'll just delete you. Now it turns. So let me mate them to each other instead. You and you. I'm going to lock you guys in to be parallel. And then you and you. Parallel. There you go. That should work. Yeah. Now it's not upset anymore. So there you go. So if I pull these out, the one thing I will have to do is there's a mate I will have to delete because I have to pick the face of this object to mate it correctly. Mate's the term they're using, that's why I'm using it. There you go. There's a lot of mates in here right now, so this is the one I need to delete because I just hit the delete button on my keyboard. Yes, because this is the one I need to be able to pull these out. See that? You will find that your assembly will look a lot cleaner if you separate these out. Okay, just a word of advice. There's a couple ways to do it. For today's video, I'm just showing you one method. This isn't the only method or the only way to do this. So I'm going to hit save. You'll notice I keep hitting save, 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 and save often. Whatever you're doing, rebuild the document, of course, and hit save. Now we do have a problem. Obviously, this base is incorrect. So if I go ahead and edit the base in place, one, it's obviously missing holes. Two, they need to be tapped holes on top of everything. I'm going to go back out, and I do actually, for the purpose of this conversation, I do need this and this to be flush. I hit OK because I need to know where a couple things have to go. So I got to edit that part in place. I'm going to go ahead and slice it. I hit OK. That way I could see exactly where my problem is. So if I look back at my assembly, my PDF, which I think I accidentally closed. So let me look one more time. There we go. It says 2x M12 by 1.75. So it's got knows what kind of fastener to go in there, but it has not identified, obviously, the details of the drill and the tap. So I can actually use my part that I have here to figure out that information. It's not that straightforward. And some people will say it's not worth it. So what I'd like to say is I'm going to show you a halfway solution, and then I'll do a separate video, independent of class probably, to show you how to create a fluted hole. So the hole itself is also literally tapped. The method I'm going to use right now is actually the more common method, which is I go online and I find out drill size for a, what is this one again? See how it knows what I want to do.
I think it's
It'll open
12,
up.
12
Yeah, I gotta find that. Hold on. For an M12, yeah, because it doesn't matter. It's an M for M12.
125 because yeah.
Yeah. 125 tap. There you go. So when you do that, you'll see the tap size M12, and then you see the drill size 10.9. That's literally the size of the drill to drill the hole, and it has to be, because this is a female thread that we're making. It has to be physically smaller, because then it gets tapped where it gets the threading put into it. For those of us that have drilled and tapped holes, that's how you make a threaded hole. So in our case, I've got the basic geometry here, but I want to save myself some time because I am lazy. So what I'm going to do, I have to maximize this to get full access. Sorry. I am going to go ahead into Sketch. I'm going to create a sketch on this face, and it's going to be a new sketch. And I'm going to convert entities, but what I'm converting of all things is my hole. If I can touch it, I might not be able to. I might have to pick the outside shape. I can't access the hole clearly, but I can access this. This is the diameter at the top. Or is that the fastener? Nope, that's the fastener. Let me try that one more time. Convert entities. Come on, you can do it. Oof, it doesn't want to do it. All right, but I can, what can I select? There it goes. See how I just want to select that. I can't touch, there we go. That's really what I want to select, is the hole itself, but you see how close I have to get to find it? So you have to be patient. Found it. Okay, now the purpose of me doing this, hit okay. The whole purpose, the whole, no pun intended, or every pun intended, is that now my position is married to wherever my assembly piece is above it. Turn it into construction, okay? I rinse and repeat that action on the other side. Now those two objects are actually connected to each other. Whenever one changes, come on, same problem, you'll notice that's the exact same problem as I had on the other side. Here we go. Now I have my positions for my tapped holes. So that's the whole reason that I did this. I could do this inside. There's two ways to do this, like everything else. I could do this inside creating a hole using the hole wizard and just create this in there. I just chose to do it differently. I'm done with my sketch. Those are my reference sketches. I go to my features. Remember, pick the face first, then you go to hole wizard. Now I can go ahead and make a hole. That's going to be, this is something new, we haven't done this before. It's going to be a tapped hole. So I can do this guy right here, straight tap. Okay? It'll be for metric. It'll be an M what? What was it again, an M12? 1 point, see that? M12, 1.25, see that? How deep? Let me look at the PowerPoint. Not right now. Why does it keep closing out? What was the size of the?
That I think it's 20.
Yeah, I'm trying to find it again. Like every time I minimize it. Open this thing up like 5 times. Okay, what size? 20. Yep. Depth is 20. Okay, anticipate it being a traditional setup as far as how it's physically in appearance. It's cosmetic, it's cosmetic, it's cosmetic, it's cosmetic. Okay, this is the one you want. It is not going to create an actual sweep to show the thread. I will show that, but I'll do that in a separate video because it'll take too much time. And it's already 10:30 and I know class ends already, but I'll keep going. Okay, when we go to position, we're going to pick the two positions where these tapped holes need to be, and then we're going to hit OK. So now they're in there. They are technically tapped, but they don't visually look that way. Please be aware of that, okay? The only place you're going to know that they're done correctly is in the assembly drawing itself, the detailed drawing of the assembly. That finishes this piece of it. I'm going to hit save so I could show you the second step, which is the detailed drawing. And that's where I'm going to show you that you do see that it is tapped, but you won't see it in the manner that most of you are going to want to see it. One thing I do need to do is pull these back out, because that was the other advice that I gave you, was to make sure not to put these in the part. They'll make your assembly look less cluttered if you have them pulled out.
So it has to be exploded.
Yeah, for the assembly, I know it's a visual thing, because normally when we do hand drawings, like if we were in the hand drawing class, you could do a simple thread. In here, because these are literally threaded, it's not going to do that. It's going to actually show the thread, and I'll show you in a few minutes here how that looks. So if I switch over to here, I forgot, how do we fix this? Do we all remember? Where do you have to have your sheet? If you don't save it in the right spot, what happens? Do you get access to your border by default? You have to turn off this. You got to go browse for it. In my case, I did not. So I'm going to X out of this real quick. I'm not going to save that. File, new. Instead of saying make drawing from assembly, I'm just going to pick new because I want to create drawing and I want to use my, did I get rid of it? Yeah, you know why? Because I'm on a new computer. I don't have my border anymore. Forgot to carry that over. So I'm not going to go in a whole conversation of how to create your border. That's another PowerPoint, so I'm ignoring that one. I'm sorry, another video that's already been posted. I am going to pick my drill jig right there. I'm going to hit, no, I'm not going to hit browse. I'm just going to select it. And I'm going to drop it right there. You see what I mean about how it looks? Oh, that's pretty. I'd almost do it in isometric, but we're going to do it the way that the customer wants it. When we are going to keep the top view though, and I'm going to delete the front view, because the way the customer is looking for this, they actually want this as a sectional. So if I go ahead and see what's the scale going to be on this guy. What scale? Half scale? What do we agree on? Half scale, I think. Half scale is doable with the correct border. Obviously, I've got the wrong border, so I'm going to edit it real quick. So ignore what I'm doing. I'm taking the hatchet approach to fixing the border. As you could tell, just a real quick down and dirty solution. There we go. Okay, so you'll see, look at that threading. It's gorgeous, but it owns the drawing. You can't do a simplified thread. You cannot do a simplified thread. I think half scale is too big. Quarter scale might be too small. So I think I'm gonna pick custom and go somewhere in between 3/8. Okay, so there it is. And then remember, it's notorious for not showing hidden lines, right? Remember that? In this case, I don't care that it doesn't show hidden lines, but just be aware for all your detailed drawings, like component drawings, that you have to have hidden lines on. Now I go to view layout, I go ahead and do a section. We've done section views already, so this is straightforward. I'm going rather quickly for this piece because I know you know how to do this. It is asking, okay, let me take a step back, 1 second. It is asking certain questions. I select what kind of section you're gonna do, you know, that piece. When you hit OK, because this is an assembly, you're going to get this, which is a little different. So it says list of components. So sometimes you can exclude components from being sectioned. For example, let's just say we don't want the fasteners done, just for fun. And then we're going to hit OK. You see how only the fasteners I literally selected were not sliced? Okay, let me do that again. One more time. That's what you can do differently when you're sectioning an assembly. Okay, back down, right here. We're going to hit OK. Again, you have to select all the items that you want to not section. Now remember, we had mirrored these 3 items. So we have to, by default, see this? Mirror, not the end bracket, because we want that sliced, but we want to mirror, we want to include in the not to slice part, these guys. But what do you see? Doesn't want to select mirror. If I select these, okay, now when I hit OK, it does it so that you have, I gotta hit OK for you to see the final product. There you go. It does it so all of them are not sliced. That way your fasteners are not sliced. The only thing that's sliced is the components, the manufactured pieces. What is annoying for those of us with a little history with making hand drawings is that it made all the hatching in the same direction. So it doesn't switch the direction of the hatching. And yeah, you can adjust anything, but for the purpose of this lecture, I'm going to say leave it alone. It does at least show different type of hatch pattern for the 2 different items. And literally, this is your assembly. That's what it basically would look like. Can I fix it a little bit? Yeah, there's a few things I want to fix. Now you'll notice that it says scale 3/8 over here, and the scale of your drawing is 1/4. I would recommend that you change the scale of the drawing. Come on, you. There you go. To be what you want the whole thing to be. So when you look at your sheet and you want to go to the properties, just change it to 3/8 here. Next view, next datum label, change that to B. This guy, you still, of course, have to change that to, come on, you. There we go. Change that to A. Okay, make sure your sections are correct. Please do that. This doesn't require that bottom piece anymore because now it is the same. Whoops, I just accidentally deleted that. It is section AA and you don't need a scale. Now for the fun part, the bill of materials. When you go to annotation and you go to tables on the far end, you have the choices of different. Yes?
You can see the top, the hole that is tapped.
It will not show it as a tapped hole in the section in here as default settings, no.
Okay.
So over here, it doesn't show, I know that, which is annoying. At the part level, it'll show it if I didn't have it through. I think one other way I could do it is, nope, doesn't care. Design annotations. No, it's not just like when we were doing some of like that sectional view, the offset sectional view. It is literal in how it behaves. So, and it doesn't, this technically doesn't have a thread in it. And like I said, I'll do a separate video where I will show you how to put a real thread in this thing. But generally speaking, we don't put full-blown threads in parts anyways, because as you can tell, it gets visually challenging. This is a very dominant image on the screen.
Yeah,
And
thinking
yeah,
that you cannot change it here from.
no, to make it simplified thread. No, that's the problem. You either, that's 3D modeling is literal. It doesn't distinguish. It doesn't have that kind of coding in it yet. And to be honest, sometimes that's a good thing. As I always have reminded people, if the product does too much, then you're out of the equation. Now, one thing I do notice, let's see, this doesn't quite look centered, so that makes me a little nervous, but for the purpose of today's conversation, you can go ahead and edit your drawing, and I've already shown you how to edit your models and correct things. So I'm gonna leave that part to you. What I wanna show you is how to deal with a border, with a bill of material, and tweak that. That I haven't shown you before, so I wanna make sure that's in this video before I stop it. So once you have your views settled, you obviously need bubbles so people know what's what, and you need the bill of material so people know what components are what components. So over under the annotation tab on the far right are your different tables. You pick bill of material, you select the item, it doesn't matter which one, it's the same thing. You do have a choice of levels, top level only, parts only. Now, I do have to explain this one. Top level is, let's say within an assembly, I had a sub-assembly. Top level would not give me all the parts of the sub-assembly. If I wanted a master sheet of literally everything, like in a car, for example, a car has a door, several doors, it has a hood, it has a trunk, it has an engine inside of it, right? Well, each of those components I rattled off also have components. So your engine could be seen as one item, engine, V8, whatever. Or you can literally see it as everything that makes that engine. That's the difference between these two, okay? And indented is showing you the subcategory of one of the top levels. So we're gonna leave it at top level because ours is a very simplified assembly. The standard configuration, nothing fancy. Display one item at a time. Nothing fancy. We're not doing anything unique over here. When I hit OK, it automatically drops this. Don't ask me why Solidworks puts quantity at the end, but you can actually move your mouse over it. When you see that arrow, you see I'm wiggling it a little bit. You can actually hold it down with your left mouse button and drag it over to where you want it. So how many of you found that one? Or that was annoying, right? I think. Okay, I hope. Nah, usually is. Getting that bill to appear the way you want it to, that's a piece of it. So you can actually drag your columns around. If I look at the assembly handout, the other thing we wanted done, nope, that's that one. Where's this one? Where's the one with all the notations? There we go. Where's the markup? There it is. When we look at this, we want item number, quantity. Now, item number, if you put your mouse between them, it acts just like Excel, and it does actually use Excel. If any of you are unable to use this, the reason might be you don't have Excel on your computer. Because if I remember correctly, it is tied to you having Excel working on your toy. Just a heads up. Anybody having problems trying to create the bill of material? This could be a historical issue, but it's just something they had to deal with in the past. So we have item number, quantity, part number. Now you notice a part number you see for McMaster car parts. See how it just automatically pops in, which is beautiful. We don't need description. We have material. So we could change the language. Instead of that saying description, just double click on it and change it to material. And then you can account for whatever material you want. And that's it. One thing I do recommend is not middle center. I do recommend, right here, not center alignment. I do recommend left alignment for whatever you put in material. So the base, if I remember correctly, got to look at the PowerPoint,
I would like to have description because.
If you want it, you can. You could change it to description. I don't care. And then you include the material in the description if there's a preference.
Yeah, because the screws that we bought in my car only has a number, so I don't really know what it is.
Okay, I'm with you on that. That's okay. So you can go ahead and do that. So then you can go in here and basically fill that information into here. So your base can be, see how it says keep link or break link. It's linked to the property of an external model. Do you want to keep the link or break the link and override the value in the BOM? You'll notice what that's saying. That's what I wanted you to see. See that? You can go in here and manually tweak whatever you want, or you can actually open up your parts. Hold on, I gotta open this up. When you look at your, whoops, right here. I accidentally created another sheet. Sorry about that. Come on, zoom in, zoom in, zoom in. You can actually add this information to your part. Okay, so when you open up, when you go into each one of these subcomponents, all right, and you open that part, so there it is, and you do see that little dash, so it knows it's tabbed. It's not the best thing, mind you, just wanted to let you know that. You have all this information that you can add regarding this part, different types of information about your part, whatever it is that you want to do. So if I right mouse button and document properties, these are just the properties of the document. But if I have my part information where I have the appearance, I could change its appearance, I could identify what material I want it to be. All of this adds to the content that you can put inside as part of the part itself. So you can do whatever you want in here, and then it appears over there. So I'm going to leave you as a teaser to look up how would I add more content about my part. I'll leave that to you because I'm at 10:54. I'm not going to do it for each one. I'm going to leave that to you. What I want to show you is, because I've got to show you the balloons. I'm going to throw in balloons. This, you can actually individually attach the balloons to each item. See that? Okay, this is one method, not the only method. One method, not the only method. One method, not the only method. Okay, so you can go ahead and select these items. See that? And yeah, you could literally select all of them just so that it's in there the same way that that it is in the handout. Because I think in the handout it does it to all of them, right? Which is typically not how we do it. Yeah, it like identified everything. So if I look in here, hold on. If I look in here, now you notice this is 4 and 4, right? Item 2, I can move that guy over. But if I have item 4 and I want item 4 to be pointing to 2 items, okay? You have the ability, to go ahead, and I want to go ahead and I don't want to reattach it. What do I want to do? want to go ahead and add an arrow to this guy. So if I look over here on the different styles, flag, note, bank, that's just the notes, it's layers, quantity, so that. See how it denotes, I don't want the value included in my bubble, but let's say I want to add another leg to this. This is to reattach it. I don't want to stack it. I don't want to copy it. You'll notice how difficult it is to find what you're looking for. This is to add more information. See over here where you've got the balloons, multi-jog leader. I can select that and I can pick this guy. Come on, you. There we go. And that's about how you're going to get that. Did you see that? The multi-jog leader under annotations, multi-jog leader. Then I can add that second item. You see how, it's attached. Woohoo. See? It's not obvious, right? Literally, that's how you would add another leg to that leader. It's not obvious though. Now you'll notice you'll see some oddities here. That's because the nuts, I did not align them like I did these guys. Remember how I made a point of aligning these so they look good? These guys I did not align. They don't look as good. The nice part is I can fix it. So if I catch anything I don't like, I can go ahead and open my assembly. I can go ahead and pick that, go ahead and make them. I don't want them to move out. I just want them to be parallel. It dragged them all the way. Let me drag you guys back in. See that? Whatever I do in here, when I rebuild it, and I X out of here, automatically updates in here. Isn't that beautiful? Please remember that. Okay. Now you've got everything identified. I am leaving you with one small thing that you'll have to figure out yourself, which is description. There's a few ways to do it. The most common method people choose is this one. When you do this, I would say keep link, and then it'll actually, what was the base? What was it called? 1020 steel? Something like that? I forgot. Made from 1020. I forgot what it was. I'm just going to leave that in there. Okay. Keep link. Okay. That one, remember, I do recommend to the left. Center plate. Okay, I'm going to jump over to these guys. What's interesting about these is they actually come with a lot of content. So I'm surprised that the description didn't fill itself when it came to the McMaster car parts. So I'm not sure why the descriptor didn't populate on its own, because this populated part number, but not description. They may have eliminated that from their, how they do their stuff. So, but that's what I threw in there for a description. All right. And then those are these parts. What else do I need to add here? Anything that I need to make a note to? What correction?
You can change it to ISO because it's a metric view, metric.
You're right. To do this in metric, I could just, you're right. I could do that. But what else can I do? How do I fix this?
You can just change it in the
Change it where?
The options.
Yep. Tools, options, document properties, ISO, system options, believe. Hit OK. There you go. That's how quick it was, guys. Okay. Now it's showing correctly in the sense that the arrows are set up. The cut line. Let me undo real quick. I can't. accent. That's annoying. All right, I can't undo my selection there. So let me go back into here. Let's see if I can minimize the tighten. It's a huge dialog box. Okay, I'm gonna try to do it down here. Document properties. See, right now it's ISO. You see how the arrows are set up?
Yeah.
If I pick ANSI,
Changed.
watch the arrows when I hit OK. Boom. See, that setup is different. So please make a note of that. Thank you for catching that. Because it's a metric part, it needs to be shown correctly. So instead of ANSI, it needs to be ISO. Again, watch what happens to the arrows. Nothing really happens to the drawing except for that notation change. Hit OK. Boom. Okay. So please make note of that. Make sure your border is in the, I'm sorry, your title, bill of material. Sorry about that. Your bill of material is neatly organized, not wherever you feel like it. Tighten it up. You can't leave it like this so it's open on the end. You actually do have to close that up. Make sure it's right in the corner. Okay? Neat and organized. Because this isn't for me. You want to use this for your potential employer. It's not for me. So I'm looking at it as a potential employer, not as just a classroom exercise. Because you want this in your portfolio. Okay, I'm going to stop the video unless you want to ask a question that you want on the video. I will stop the video. All right, and we'll talk some more.